Hi, today we're going to be looking at these two tool battery chargers. This one is a Milwaukee C12 charger and this one is an Erbauer battery charger. Both of these came into our local repair cafe and both of them are just dead. So I think we'll start with the Milwaukee one first. So I'll just pull this Erbauer one out of the way. And I think what I'll do, I'll get my little dim bulb tester and we'll plug it in and we'll see if it's doing anything. Right, so what this device does is if there's a short in the battery charger, instead of it taking the mains fuse out or blowing any components, it'll just make the bulb light up instead. It's just a bulb wired in series with this socket, so let's plug it in, switch it on, and the bulb didn't light up, so there's no shorts there. But we're not getting any power lights or anything on here. Let's just double check that we are getting power to this. I'll just plug this extension lead into it and we'll just see if the bulb LED lights up. Yeah, so there's obviously power to the extension lead. So let's take this apart and see what the problem is. It looks like we need to remove these 4 screws at the back. So I shall just grab a suitable screwdriver. And this is a Security Torx T10. And if you've never heard of a repair cafe before, it's a charity where people volunteer and we try and help people in the local community fix broken items. It's pretty much a worldwide organisation. Right, let's have a look at this then. Let's get the lid out of the way. And we'll zoom down a bit. Right, so I shall try and find something to point with. I'll use my meter probe, I think. Right, so power comes in here. We've got a fuse, a bit filtering, bridge rectifier, then it goes through to a smoothing capacitor. So this will be DC mains voltage, so it'll be about 380 volts or so, I would think. And then it looks like we've got a switch in IC here. Now, is that a black mark or something on there? Let's try and zoom down a bit more. I'm not sure, that might just be the just like the logo on it, or a manufacturing mark. I thought it might have been an explosion mark there at first. Yeah, I think that's just a marking on the casing. And the fuse looks intact. I can see a filament of wire going across there, but we'll just double check with the meter. Let's just continue with visual inspection, see if we can see anything else. I can't see any blown components or anything. Right, I think I'll get this board out and we'll have a look at the other side of it and see if it just wants to come out, or whether there's any other screws here. So let's get the bottom out of the way. Right, let's flip this board over. It looks like we've got a ATTEN microcontroller there. That'll probably be the brains of the charger. I was just wondering if those were some dry joints there or something. But I think that's a programming header, or place for a programming header, because it's not populated on the other side here. Yeah, VDD, VSS, looks like serial data in, serial clock, serial data out, reset. Yeah, so that's definitely a programming header. And we've got a 6 MHz crystal. That obviously provides the clock for the microcontroller to make it run. can't see anything obvious at the moment. That's it, no signs of any exploded components or anything. Right, I think the first thing I want to do is just check that this mains capacitor hasn't got any voltage left in it. So I'll just zoom out a bit so I can get the meter in shot. And we'll just go into volts DC. Yeah, that appears to be okay. That'll be these resistors here. What those will be for, they're bleeder resistors, and what they do is if this capacitor's fully charged and then you unplug it from the mains, it slowly discharges the capacitor through these two resistors here. That's why they're across the capacitor. Right, so this is safe to work on anyway. So I think we'll start by checking the fuse, which is just here. So let's go on to continuity. Right, so fuse is intact. Let's go from the plug end, just in case there's something wrong with the plug. So let's go on to the live, and then it goes to here. And get my probe on properly. Yeah, and then it goes through the fuse to here. And then it'll end up on either this pin or this pin. So this one should be the neutral. And it is. Right, so we know we've got live and neutral from the plug up to this point here. So we'll check these diodes. I'll just see if they're okay. I'm just going to diode check so I know it beeps. Right, so that one's okay. And that one's okay. Let's just reverse the leads. And that one's okay. And that one's okay. So the bridge rectifier is okay, and the fuse is okay. So we should have power on this mains capacitor. So I think what I might do next is just plug it in, and then we'll see if we get voltages on this mains capacitor, and we'll see if we get any voltages on the output. So these are the outputs of the transformer here. And we've got a large capacitor here, so I would think that'll be on one of the outputs, yeah, so there'll be a diode around here somewhere. Let's just have a look. Yeah. So that's the rectifier diode. So what happens is this DC mains gets switched at a high rate, at a higher frequency by this switching IC here. It then goes through this transformer. So we've got high frequency AC coming out of this transformer, and the reason why they do this is for efficiency. Also use a smaller transformer than you could with a traditional linear power supply. So that's why they up the frequency. It then goes through a high speed diode, which then converts this high frequency AC back to DC, and then it goes into the capacitor here, which then smooths it. So we should get a voltage on this capacitor here if this power supply is working correctly. So I'll get the dim bulb tester. I'll just double check where that capacitor is. It's just there. I'll just zoom out a fraction. Right, so I'm going to plug this in now. Right, so this is now live, and obviously be very careful if you're working on live equipment. Don't copy what I do. Right, so let's see if we have mains AC on here. And we do. at about 340 volts. Let's see if we're getting anything on the output. Nothing. Oh, actually we are. Interesting. So we do appear to have some voltage there. Now, these are 12 volt batteries, so we should have more than 11 volts coming here. Right, I'm just going to unplug this and switch it off for a moment. I'm just going to let that capacitor discharge. You can see discharging there. So, it does appear to be switching, but we seem to have a reduced output for some reason. I wonder if it's capacitor related. So, my first thoughts are, I'll just zoom down a bit. Capacitor here possibly. Possibly one of the smoothers, but possibly not. What we've got here. It looks like we might have two power supplies on this. So we've got another output on the power supply just here. I'm not sure where that goes. I'll have to see if I can trace that through. It looks like it goes across. Or maybe not. I can't tell which component that one is. It's not like a capacitor there, is it? It seems a bit odd. Ah no, it's the diode down there. Yeah, I was going to say it should go through a diode first. So the other power supply goes through this rectifier diode here to this point here, and then it looks like it goes through another diode to this point here, which is that smoothing capacitor there. Now that actually might be a ferrite bead, because I've just noticed there's FB3 there for ferrite bead, but I can't see what it says underneath that one. So possibly one might be a ferrite bead and that might be the rectifier diode. Yeah, that's a ferrite bead, that. And then that's the rectifier diode. So we could possibly have a short somewhere. That's the other thing. So let's go into diode check again. Right, so that diode's okay. That seems a bit strange unless we've got power in this capacitor still. Yeah, we've still got 6 volts in that capacitor, that's why. That's why I was getting a bit of a weird reading on my meter there. So at the moment I'm not too sure on this one. I think we'll have to start taking components out and checking them. But like I said, I can't see anything obvious, but I would suggest a capacitor for some past experience. So I think the first one I'm going to take out is just this one. We'll just see what that measures. Right, let's get the iron out. And I'll just put a little bit fresh solder, I think, on that first, just to make it easier to remove. Just clean those holes up with a bit of solder wick. There we go. Now we'll just give it a bit IPA and a cotton bud just to clean it up. Right, let's grab my little component tester. around 46.87 microfarads. And it's 47, so I would say that one's probably alright. Let's just pop that back in. So I wonder if there's a short somewhere further down the line on this. It just seems a little bit odd while this is only running at 11 volts when I would have thought we should have at least 12. I did have a power supply similar to this. It was a Milwaukee one where one of these diodes had failed. So I might just check these two diodes down here. Although I think that one was just totally dead if I remember. Let's just go into diode check again. We know the bridge rectifier diodes are okay. And that one seems okay. Let's try if we can get to the one underneath it. That one seems okay as well. 2.7K, so that's right. I mean, it could be a problem with the actual regulator, but I doubt it. The actual switching IC, but we do have a Xenon diode there. I think it's because we've still got power in the area. Right, let's see if I can discharge this capacitor. Let's see if we get better readings now. Yeah, so that diode's okay. I already checked this one, but let's just double check. That's okay. We've got another diode here. Let's try zoom down a bit. That one's okay. I do have a transistor or something there, but I can't see the number on it. Yeah, C1815. I'm just looking at these capacitors here just in case there's any sign of leakage or anything. Like I said, can't see anything obvious up to now. I wouldn't have thought it would be that capacitor, but could possibly be one of these smaller ones could be causing a problem. I think we might take some of these out next and we'll just double check those. So, looks like that could be a voltage regulator here with a capacitor on the output, which is that little one there, and a capacitor on the input, which is that one there. And it looks like this transistor here switches it. Looks like that switches power to the voltage regulator, possibly. Let's just see what happens if we plug a battery in. Why let's like this in bits. I'm just curious. I just wondered if when we've taken it apart we've kick-started something or... Right, let's put that like that a second. I'm just going to plug this back in. Let's make sure everything's out of the way before I switch it on. Right, so we still don't have any power lights. I'll switch that back off and unplug it again. But obviously this is still going to have a charge in it. We actually had slightly higher voltage there. I'm going to switch this back on again. And I just want to see if we're getting any voltage to this microcontroller and that. Right, I'm just going to plug this in again now. I'm just going to switch it on just now. So as long as we're on this side of the board, we should be okay. This is the isolated side. So I mean 11.43 still seems low to me. And this is our ground. Let's just see what we get on this pin here. Nothing. 0.5. Nothing. So we've only got 0.5 volts there. I'm trying to see where that capacitor was. That is on the output. I think it was across here. Interesting. We only seem to have 0.5 volts coming out of this side. And I think that's why it's dragging the other side down. So I think we're getting closer to finding out what the fault is here. So there could possibly be a short on this rail. Right, I'm just going to switch this off again for now. And we'll just let that capacitor discharge again. And I'm just going to discharge this capacitor just with a bit of solder. Oh. Ah, you know what I've gone and done? I've gone and shorted across the diode and blew that. I thought there was the capacitor, but the capacitor's here. Well, it just goes to show you, I do make mistakes. That's not good. Right, now we need one of those. I'll have to see what that is now. Let's see if we can zoom down a bit. Right, I'm probably going to bring the microscope in or put a magnifying glass to see if I can see what that is. Oh dear me. Right, I'm just going to find my magnifying glass. Right, I've managed to clean that up a little bit. And we can see the number there. And it's a 17P06. Now, I'm not sure why that sort of just blew up there, because that feeds the output that goes to this red wire here, which shouldn't have been connected to anything. And the power supply wasn't on, so even if I shorted across that diode, it wasn't like we were pumping AC directly into this thing because the power supply wasn't on. So I'm not sure why that just went pop just by discharging the capacitor. So that's a bit of a mystery, that one. So I'll have to remove that now anyway, and we'll see if we can then diagnose what actually is the problem with this. What this MOSFET seems to be doing is switching the supply to the output of the battery, so we can stop it from charging and switch it on charging pretty much. Right, I'll remove that and then we'll see where we go from there. I'm actually going to put some flux on this first, and I might just touch it up with some leaded solder first, just so it's a bit easier to remove. Might have been easier just to snip the legs on that actually. And we'll try that. I'll just snip the legs, and then we'll just use the soldering iron to remove it, save the hot air. Might have to turn my iron up a little bit. There we go. Right, let's use some solder wick and we'll try and remove those legs that are left. And then I'll just give that a bit clean up with some IPA. Right, I think that'll do for that. Let's just check if that resistor's intact still. I'm not sure what reading that was, but I don't think it was 100k. I can't quite tell. I'll probably have to bring the microscope in for that one, or look at it through the little spyglass. Let's see if I can see what it is. It says 01D, so it actually might be correct. I don't know why they just don't keep them to standard codes instead of like 01C and 01D, for instance. I still haven't found the actual problem on this yet. But it appears to be on this winding here. So we'll come out of the winding, go through a ferrite bead, through a diode. We have a capacitor here, so that's a ground, and that's the positive of the capacitor, but we're only getting 0.5 volts on there for some reason, and I don't know why. Let's just take this capacitor out, we'll check that one. And let's see, 100 microfarad at 35 volts. Let's just pop that in the component tester. I'll just make sure it's got no charge in it first. And it doesn't measure too far away, that. So I don't think that's the problem. Just pop this back in. I'm just wondering if we should try the thermal camera just to see if anything's getting warm or hot. I'll get this capacitor back in. I'm just going to double check that diode. Zoom out a bit so you can see the meter. That's just because there's charge in the capacitor there, but no, that's okay. Right, I'm going to plug it in. We don't have that MOSFET in there now. And then I might get the thermal camera out and we'll just see if we can if I see anything getting warm. And that's just bleeder resistors. Well, there doesn't appear to be anything. Now I can see that's getting warm on this side of the board. Right, I'm going to switch it off. I'm just going to flip the board over. Let's check there's nothing underneath it. Right, we'll switch it back on. Well, the only two things I can see getting warm are those two capacitors. So that's not really telling me a lot either. So I've just been having a little think about this. And what I'm going to try, I've got one of these little automotive bulbs, and I'm just going to connect that on the output here, just to see whether we're actually getting a proper output of this power supply. Because I can't find any shorts on the output. I'll just tin these up. And we'll just use this one as a ground. Right, so a little automotive bulb wired up there on the output. I'll just get that solder out of the way. Right, I'm just going to switch this on now. And the bulb's not lighting up, so are we getting any voltage here? No. I'm starting to think it's on the input of this. Something to do with the switch inside. I wonder if that regulator IC is faulty. I mean, I haven't really had a regulator IC go faulty like that. They normally just blow up. But you never know. The internal MOSFET could have half failed or something maybe. Right, I'm going to remove this bulb. I'll just check that we haven't got any voltage in those mains, in the mains capacitor. That should be fine. Let's remove this regulator. See, I'll just grab the nut with these side cutters. Right, I'll zoom down a little bit. I think I'll use the solder sucker for this one. I'm just going to apply some fresh solder first, just to make it a little bit easier. Might be worth trying some low melt solder on this. I think it might make it easier to remove. Right, there we go. I'll just use some solder wick now just to clean this board back up. Just put a little bit of flux on there first just to help remove this low melt solder. Right, I'm just going to clean that up with some IPA. Right, I'll see if I can find a replacement IC. Right, I've had a look around and it just so happens I've got one of these ICs. I think I bought this one for a different Milwaukee charger, but then it turned out to be something else, so... Right, let's fit this one and see if it sorts the problem out. And then we'll still need to sort out that problem with the MOSFET that I caused, but... I don't know if all those holes are clear. Yeah, there's one of the holes there isn't quite clear. Right, I'll just see if I can sort that out. A bit of a weird pin arrangement on these devices. There we go. Right, let's see if I can grab that nut with my tweezers. Because it doesn't want to go back on. Right, let's solder that back up and we'll see if that makes any difference. Right, let's give that a little bit of a clean up. Right, let's see if it does anything different now. Tell you what, I'll leave it that way. I'll zoom out a bit and I'll just get the meter in shot and we'll beat the... So I'll put that light bulb back on and we'll see if the light bulb lights up. Right, let's plug this in and I'm going to switch it on in 3, 2, 1, and it hasn't made any difference. So possibly not the top chip then. So scratch my head a bit with this one at the moment. So I've just disconnected the bulb. I'll just switch it back on. And what I've noticed, I'm only getting 1.5 volts out of there now, since I've replaced the IC. So I think there's something wrong on this side. I know we didn't change this capacitor, but I did take it out and check it. And we do seem to have 5 volts there, because that's the supply that actually regulates the chip. Oh, it is jumping around a little bit there now. Interesting. As it looks like that capacitor gets fed from those 2 resistors there. Anyway, I'll just wait for that capacitor to discharge. So we've got 2 resistors here, which is what feeds this capacitor. So let's go into ohms. And that one measures about a meg. And that one measures about a meg. So those appear to be okay. I mean, there's not really much else on this side of the circuit. I don't appear to have any dry joints that I could see. I've got a small resistor here. I'm not sure if I can see what size that is though. Looks like 8, 9 and then a Y, I think. Yes, that says 8, 9 and then Y, so I don't know what value that is. I'll have to look that one up, I don't know what it is off the top of my head. Another small resistor there, which is 682, so 6.8K. Close enough. I don't know what this one is. Seems to be fluctuating a bit. I'll see if I can find what value that resistor's supposed to be. Right then. 89Y is 8.25 ohms. And we're not getting 8.25 ohms there, are we? What an unusual value, 8.25 ohms. So I think we might have found the problem. So I thought I'd bring the microscope in just so we can see this a bit better now. So this is the component here, which is 89Y. I'll just get the probes on here. You can see there we've got 220K or so. So I'm going to remove this resistor. I'll just grab some solder. Just give that a bit of a clean up. And I managed to get a replacement resistor from another Milwaukee power supply that I had lying around. And this one says 8R2. Maybe a bit hard to see there, but I'm not quite happy with the way that joint looks as well. Right, let's see what that measures now. About 9 ohms. Right, Right, so that resistor was definitely faulty. Let's just see if we've got any shorts on anything else. So I wonder what caused that to fail then. That looks like the ground wire going to the capacitor that feeds the switching IC. Right, I'll get the microscope out of the way and then we'll see what happens next. Right, let's solder this little bulb back on. Right, let's see what happens when we switch it on now. I'll zoom out a bit more so I can get this. Oh, well, it did light up bright for a second and then cut off. Right, well at least it's doing something more than what it did. It may be sensing too much current, or the microcontroller might be closing it down. I'm not sure, because there is some regulation in here as well. But at least we've got the full output there now, and it did light the bulb up. So I think the next thing we're going to have to do is try and find a replacement MOSFET for the one that I kind of blew up. Right, back momentarily. Right, I found a replacement MOSFET. It's not quite exactly the same number, but it's being used the same way out of another Milwaukee charger that I had, so let's try that in it. I've just checked the specifications of it and it's the same current rating, and I think the voltage rating's slightly lower. I think this one only does up to 40 volts, but seeing as it's only switching 12 volts in any case, or just around about 12 volts, I can't really see it making a lot of difference. That's a P-channel MOSFET, by the way. I should have probably zoomed down a bit on that. Right, let's just switch it on and we'll just see if we get any lights or anything on it. Tell you what, let's just try a battery in it. Let's just plug a battery in and we'll just leave it like that. Right, I'm going to switch it on in 3, 2, 1. Well, that was interesting. Right, I think that's actually working. So I'm going to plug it into the mains directly now, and hopefully this doesn't explode. Let's try and untangle this mains lead a bit. Right, so this is directly into the mains now. Well, it seems to be doing something, and we do have a green charge light on, or a red charge light should I say. And according to the front here, it says red means it's charging. So I think that might be it. I'm just going to get the test meter. I'm just going to carefully try and measure the voltage going into the battery. It seems to be making some weird noises. Unless that's the current regulation kicking in or something, I don't know. I mean, I think this battery was fairly fully charged in any case, so it might just be that it's getting near the end of the charge cycle, so it's just feeding pulses of power into it maybe. But it is actually charging and the charge light's remaining on, so... Right, I think I'll leave it like that for a bit and then we'll come back to it to see if it fully charges the battery. Right, I've just came back and the light's gone green. So let's just check the voltage on this battery. It probably hasn't gone up by too much. I think it was pretty much nearly fully charged in any case. Yeah, it's about 12.33 volts. Well, I'd say that charger was working. Right, I'm going to switch it off for now. We'll get it back in its case, and then we'll have a look at the other one. Right, let's have a look at this Erbauer one. Right, let's zoom down a bit. Well, it looks like we've got a fuse just down there. And it looks like we've got a screw that holds the circuit board in just here. So let's take that out. Now, and the first thing I've noticed, we seem to have a bit of a scorch mark there. So it looks like something's blew up in here. Let's see if we can work out where that scorch mark was. So in line with here. So round about here somewhere then. Where the switching MOSFET or something is, I think. Looks about where it was. Right, let's zoom down a bit, see if I can see anything. Possibly, looks like there's been something shorted across those two pins. There's a bit of a black mark there, possibly. So we've got the switching IC. Looks like it feeds the gate of this MOSFET, it probably is. Looks like there's little bits of corrosion here. So I wonder if damp or something's getting across this. So we'll look along here as well. It looks like there's little bits of corrosion along these traces. Looks like we've got a little opto coupler for feedback. So that must be one of the output diodes from the transformer. Which is just here. And then we've got another winding, goes through a diode here. So we've got two supplies again from this transformer. One probably feeds the logic, and one of them is probably the main supply for the battery. And again we've got a switching MOSFET which probably switches the power to the battery and disconnects it when it's fully charged. So quite similar to the way the Milwaukee one worked. Right, I think the first thing we need to do is check to see if this switching MOSFET is shorted. Let's get the meter in shot. And let's go on diode check. And let's see what we get across these pins. Right, so between the gate and one of the other pins, either source or drain, we seem to have about 70 ohms, which seems rather very low. So I wonder if it's fed back and damage the switching IC as well, possibly. Right, so I think the first thing to do is take that switching MOSFET out and we'll see exactly what it is. Right, just going to add a little bit of fresh solder first. And we may have to remove the whole heatsink because I'm not able to get a screwdriver in very easily at that angle. It's probably a bit hard to see on the camera, but so I might have to remove the whole heatsink here, which is those 2 points there. I don't know how well this will go with the iron, but let's have a go. I might try some low melt. So if you're interested in any of the tools or things that I use here, like low melt solder, there's some links in the video description. There's a load of glue on there, that's why it wasn't coming off. Right. So this is a 10N60. And that might be because I've just sent voltage in and it's what's called gated, which means we've switched the MOSFET on. So this MOSFET might actually be working. Yeah, I'd say that MOSFET's actually working. Yeah, we've switched it on there, so if I do that and now measure those 2 pins, it should be off, and it is. Right, I think that MOSFET's working. So let's have a look at the rest of the components on the circuit. So I'm just wondering if something like a spider or something might have crawled in here and met its demise. That was the other thing I was just thinking there. Right, let's just zoom down a bit. Right, let's start at, oh, I don't like the way that wire's sort of crimped there. Right, let's start at the plug end. Perhaps I should have done this first. And let's just trace through just to see if we're getting power through. Right, so fusing the plug's okay because we're getting continuity to there. Then it goes through a fuse, and the fuse is actually intact. It then comes through some filtering, and some more filtering, to the bridge rectifier, so we'll just check that the neutral comes to here. So that means we should have mains on this capacitor here if we plug it in. We've got a couple of resistors here, which I guess those feed the switching IC there. Let's just zoom down a little bit more. We've got a 0 ohm resistor there. And that measures okay. The only problem is it's got conformal coating on this, so it's a bit hard to actually see. I've got a resistor there. Let's go on to resistance. And that measures 47 ohms. I can't see what it actually says. Yeah, 470, so 47 ohms, and that's what it's showing me on the meter. So that's okay. We've got a 2 ohm resistor, which is measuring 2.4, so that's okay. I'm just wondering if that's shorted across there. Let's get that bit out of the way. I'm just wondering if that's being shorted across for a length of time, if it could have caused damage to the transformer. I'm just trying to work out where it's actually switching to. Right, so there's a big resistor that goes from there to there. So this is the positive, which is always going to the transformer. The negative goes through a resistor through to here and then gets switched to this point here. So do we get any resistance on these windings? And yes, we do. So the transformer may be okay. Just if that was open circuit, then obviously we've got a problem with the transformer. I wonder if they're using this as some kind of feedback here or something, because there seems to be some other windings tapped in here. Let's see if we get any shorts on any of these. Ah, right, I'll just zoom out a bit so you can see the meter. Alright, on this capacitor here, I'll just go on there again on ohms. We're getting 1.8 ohms. I don't think that's right. So it appears we've got a short somewhere on here. Now whether or not it's that capacitor or something else, like the switching IC. I don't know whether to bring the microscope in on this one so we can see a bit better. I'll go set the microscope up. Right, I've got the microscope set up. And this is the capacitor that I was measuring, just this one here. And as we can see on the meter, we've got about 0.9 of an ohm. So, if we trace back here, this is the mains smoothing capacitor. And obviously the power comes through the resistor to this pin here, but also goes to this side of the capacitor. And it looks like the other side of the capacitor goes through these two resistors to this side of the mains capacitor. So it looks like these are sort of like decoupling capacitors, probably for the main switching IC. And because there's been a short here, I just wonder if it's crossed over to possibly the gate pin, sent power back into this controller IC and short circuited. So I wonder if I can get a number off this IC, and then I'll see if I can find a data sheet. Let's try a bit IP on it. Let's see if I can see a number on it. I might have to adjust the focus on the microscope a bit. It's quite hard to get the number off this one. It looks like 2268LF, I think that is. I'm not sure what the first two numbers are, or digits. Oh, there we go. Is it CB? CB2269LF. I think that's what the number of that IC is. Right, I'll see if I can find a data sheet for that. One moment, please. Right, I managed to find a data sheet for this chip. and it's an OB2269, I think it was LF, and this pin here is ground, and this pin here is supply in, and if we measure across those two pins there, we get 0.8 ohms, which shouldn't be right. This is the gate pin, and if we measure to that one, we get 22 ohms, and if we measure between supply to that pin as well, we get 23 ohms. So I'm pretty confident that that IC is shorted. So I think I'll just remove it, and then we'll see if the shorts go, and then if they've gone, we'll order one of those. Right, I'll get the Rework station out. Yeah, I'm too happy with the noises this board's making. I might try some low melt solder on this instead, because the last time I had a board making these sort of noises it all blistered. Right, let's just put a bit of flux on here first, so this will be quite warm. Let's just put a bit of low melt solder on. I mean, it could be that this IC's got a thermal pad underneath it, because I would have thought that would have came off by now. So we may have to use the hot air. Yeah, I've seen the board blister a little bit there. No, the chip was glued. That's what the problem was. Right, I'm just going to add a bit of flux to here. I'm just going to wick off some of this old solder. And we've lost the pad. I don't think that pad actually went anywhere. Right, let's see if we still have a short. So let's go on that capacitor again. And we do have a short. I wonder if it is that capacitor. I would almost certainly thought it was that IC. Let's take this capacitor off. Let's use the iron for this. And again, just a little bit low melt solder on it. I should have probably put some flux on, but right, just going to add a bit of flux to it. Right, let's see if the short's gone now. And no. So why would we have a short across the supply? I don't know what that component is under here, if there's a one. I'm just trying to work out which way this circuit goes here. Because I mean, this doesn't go anywhere else now by the look of it. It comes in from here, goes through there, and then to there. Unless it goes somewhere else on the other side of the board that we haven't seen. That's the only other thing I can think. Right, I've just spent a little bit of time working out this circuit and then looking at the datasheet again. And I thought this pin was supply, but it's not, it's actually this pin. But if I get the IC here, what this pin here is actually sense. So the capacitor measuring short across there is probably okay. But if I get the chip here and I measure between ground and the VCC pin, I've got about 6 ohms, and I don't think that's right. So I still think this IC is faulty. So what I'll do, I'll order a replacement IC, and I think the MOSFET's okay, but because it may have been weakened during whatever happened, I might just replace that in any case, because I've got to order an IC in any case. So, right, when those parts come, I think I'll refit this capacitor, and when those parts come, I think we'll continue from there. Right, the new parts have arrived. So the first thing I'm going to need to do is remove the MOSFET from this heatsink. I know that I put a bit of thermal paste on there because the old one seems to have a little bit of thermal paste on. A little bit of this on. Right, I think that'll do for that. Right, I'll get the circuit board. We'll install the MOSFET first. Might have to remove a little bit of solder from this leg here, off the heatsink. There we go. Right, we'll get that soldered in. Right, let's cut off these excess legs with the side cutters. So I'll bring the microscope in and then we'll fit this chip. Right, let's get the replacement IC. I'll just put it roughly in place. I'm going to add a bit of flux. And I think I'm just going to solder this one pin at a time. I don't know if I'm happy with that. It seems to be sticking up a little bit at this side. I might just give that a blast with some hot air just to sort of flatten it down. Right, we'll get the microscope out of the way and then we'll give it a test. Right, let's get this leaving that out of the way and those parts. I'll get the dim bulb tester out, just in case it decides to explode everywhere. I'll switch that microscope light off. Right, let's see what it does when we switch it on. Oof. Well, something went pop. Right, let's just zoom down a bit. It actually looked like the new IC. Yep. So, is there something else that's shortened somewhere? I mean, I did check pretty much all of the other components and they all seemed okay. Right. Well, I suppose I better take that IC off again then. Now it's got a big hole in it. Well, luckily I've got some spare ICs. Well, I don't know why that one's failed. I mean, I did check pretty much all of the components around here and everything seemed okay. And I did work out a little bit more of this circuit, how it works. I think once it's up and running, it actually uses this tap on the transformer. It goes through this resistor, through this diode to a capacitor here, and then it uses that to, via this Zener diode here, to regulate the supply to the chip. There's another capacitor here. So the only other thing I could think is, has one of these capacitors failed maybe? I haven't had those out. That's about the only thing I haven't really tested. I mean, let's just check some other things again, just to see if anything else has blown since. So I mean, 2.8 ohms or 2.7, that's fine. Let's just go on diode check and we'll check this rectifier diode. That's okay. We've got a Zener diode here. Let's just go the other way. That seems okay. We've got a 10k resistor there. Let's just try that. That's okay. Let's just try this transistor. Try the other way. Right, so that seems okay. I'll just untangle my leads a moment. We've got a 47 ohm resistor here, which is actually measuring 29. Let's just double check that diode. I mean, it could be that that diode's gone faulty, but that could have happened since. But I'm sure I checked that diode before. Let's check that resistor there. And that one measures a bit weird because of this capacitor measuring weird, I think. And check that 0 ohm again. So the only thing I would really think is possibly capacitor here, capacitor there, and that diode. We'll remove the chip again first, and then we'll have a look. So I've removed the IC, and I've moved this diode over to one side so I can measure it. The one that's got the 47 ohm resistor across it. So I'll just check that resistor still measuring. Yep, 46.9. Now if I go into diode check, then we'll go across the resistor, the diode here. We'll swap the leads around. So I'm not sure whether I've measured that or not, because with it having the resistor across it, I don't think would have been able to measure that. So I might have missed that one accidentally, and it would be the one that's blown. But I've checked most everything else, and everything else seems okay. So I think we'll try replacing that diode, refit a new chip, and then test it again. Now, instead of ordering one of those diodes, I've had a look at my old scrap boards, and in true MacGyver style here, I've got this old board, I think it was a hoverboard that I got off someone, and it's got one of the diodes just there, T4. So I'll remove that one, fit it to here, and then we'll see if it works. So I've refitted the new chip and the replacement diode, and I just thought I'd check these capacitors. I was going to take them out, but I was just going to check them quick with the meter, and that's supposed to be 47 microfarads, and it's measuring 45, so I assume it's going to be okay. And there's another capacitor here which is 10 microfarads, and it measures 10 microfarads. So if I was getting, off readings, then I think I would replace them, but let's just give it a go like that. Let's see if that chip and that diode has made any difference then, or if it's going to blow up yet again. It's a good job I've got to supply these chips, isn't it? Nice. In 3, 2, 1. Right, well yeah, I heard something. There's definitely something not right there. Definitely something not right, but I'm not sure what. Let's just try it, see what pops. Well, nothing popped, but the light was lit up continuously, so I think it's just going to blow up if I plugged it straight in. Well, I'm a bit stumped with this one at the moment. Well, I've got quite a collection of parts here now that are blown up. So, I wasn't having much luck with this, it just kept on blowing up. So, what I thought I'd do is try the original MOSFET back in. I mean, these ones came from AliExpress, and they did give slightly different readings to the original one. So what I've done, I'll just zoom down a bit. I've replaced that diode yet again because it had failed. I've replaced the chip yet again. I've checked pretty much every component on here now, and I can't find any problems with any other components. And I've put the original MOSFET back in. So let's give it one more try. Right, here goes. I'll just get ready to plug it in and switch it on, and let's see if it goes pop yet again. Well, it didn't go pop. Ooh, hang on. Can I move this? I'm trying to think how to move this now. But I think we've got a power light. Just there. Green LED. I'll just switch it off, see if it goes off. It might take a while. I think it's a power light. It's not just a reflection, is it? No, it seems to... I'm not sure. It might just be a reflection, actually. Did that work or did that not work? Hold on. I'll put it that way. Let's try that again. Yes! I've been pulling my hair out with this for about the last... I don't know, about the last hour or so, and just not getting anywhere with it. And I just thought I'll try that original MOSFET back in. So I'm not sure whether there's some kind of difference between these 60N10s and the original one, but that seems to have fixed it. So I don't know. Right, I'll get it back together. We'll plug the battery in, and then we'll see if it charges the battery. What a nightmare. Right, let's see if I can find where the screws and everything for this are now. At least there's not many screws to go in this, so... Right, I'll just zoom down refraction. So that's two I've struggled with a little bit this time. So it doesn't always go plain sailing. Right, let's find my Torx driver. Right. Right, well, it didn't go bang, and we've got a light on, so that's good. Right, let's grab the battery, and let's plug the battery in. Right, it's probably going to flash like that because it's trying to draw current, and that's my dim bulb tester kicking in. So I'm going to plug it into the mains now. Tell you what, let's get an extension lead. And hopefully it doesn't take all my lights out. So let's plug it in. Right, looks like it's charging. We'll come back to that shortly and we'll see if it's fully charged. Right, it looks like it's fully charged. Excellent. Right, so 2 items saved from the landfill then. It's been a bit of a long day. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.